The National Aeronautics and Space Administration, NASA, astronauts have recently discovered evidence of a rapidly developing black hole, which has long been regarded as a missing link in our understanding of the early cosmos. Astronauts found the monster body, which originated around 750 million years after the Big Bang, using data from the Hubble Space Observatory. The monster, known as GN7Q, had been lurking covertly in one of the most extensively researched regions of the night sky, the Great Observatory's Origins Deep Survey North Goods North field, up until this point, according to the U.S. Space Agency. The group was able to gather proof that GN7Q is a recently generated black hole. A small source of infrared and ultraviolet UV radiation was discovered by Hubble. This could not have been created by galaxy emission, but it is compatible with the radiation that would be predicted from objects falling into a black hole, NASA included. Additionally, according to NASA until recently, rapidly growing black holes in dusty, early star-forming galaxies had only been predicted by theories and computer calculations. The most recent analysis suggests that GN7 is the first instance of a rapidly growing black hole in the dusty core of a starburst galaxy at a time close to the earliest supermassive black hole known in the universe, according to Seiji Fujimoto, an astronomer at the Niels Bohr Institute of the University of Copenhagen. Seiji Fujimoto noted in a statement, the object's properties across the electromagnetic spectrum are in great agreement with predictions from theoretical calculations. Current theories, according to NASA, suggest that supermassive black holes begin their lives in the dust-shrouded cores of vigorously star-forming starburst galaxies before ejecting the surrounding gas and dust and emerging as extremely luminous quasars. Quasars are basically extremely bright objects in the universe that are said to be powered by black holes. Although it is incredibly uncommon, both the bright quasars and the dusty starburst galaxies have been found in the early universe, according to the astronauts. The team speculates that the GN7Q, which perfectly combines the characteristics of the dusty starburst galaxy and the quasar, may be the missing link between the two groups of objects. It is important to note that this most recent finding offers a fresh perspective on how supermassive black holes rapidly expand in the early cosmos. Therefore, according to NASA astronauts, the most recent discovery serves as an illustration of a type of supermassive black hole that was previously unknown. Now the team plans to systematically seek for comparable objects using dedicated high-resolution surveys, according to NASA. Additionally, the team hopes to take advantage of the NASA James Webb Space Telescope's spectroscopic sensors to examine objects like GN7Q in unprecedented detail. Supermassive hardly scratches the surface of how enormous black holes can become. These gaps dwarf our sun by a factor of 1 million. To put things in perspective, our host star might fit 1 million Earths. The number that could fit into a massive black hole is something I don't even want to consider. Anyway, because of this, you might be thinking about a question that astronomers have long wondered. How do some black holes get so big? What's the origin of it all? Supermassive black hole formation and growth in the early universe have become a major mystery, according to Brammer. It's possible that GN7Q can assist with that. According to Brammer, starburst galaxies, or galaxies that produce stars extremely quickly, have dusty cores that are believed to be the origin of supermassive black holes. The abyss then supposedly gains a lot of heat while chowing down on all the starburst dust and gas, and finally emerges from its cocoon with a quasar or brilliant central jet. These black holes are assumed to have begun their inexorable growth in size and transformation into the phenomenon we see somewhere along the road. Although scientists have previously discovered both starburst galaxies and brilliant quasars to support the theory's beginning and conclusion, the story's middle sections are based on computer simulations. Prior to GN7Q, no intermediate object between the starburst galaxy's beginning and the quasar's conclusion has been seen. Seiji Fujimoto, an astronomer at the Niels Bohr Institute of the University of Copenhagen and the paper's lead author, said, GN7Q provides a direct connection between these two rare populations and provides a new avenue toward understanding the rapid growth of supermassive black holes in the early days of the universe. In essence, GN7Q could finally explain how supermassive black holes that reside in later epochs of the universe came to be, even though they lived during a period known as the Cosmic Dawn. The ancient chasm is so comparable to both quasars and starburst galaxies that NASA even refers to it as a potential missing link for the supermassive black hole formation scenario. According to Fujimoto, the object's electromagnetic spectrum features are in great agreement with predictions from theoretical simulations. For instance, the redness seen in the Goods North survey is probably the result of starburst dust-reddening quasar light. With this, we conclude our video. We appreciate you helping us keep it going by watching. The best way to support our channel is to watch another episode. Thank you for tuning in. To ensure that you never miss an episode, please subscribe to the channel.